Hello friends, welcome to Math Solution Academy. Now we discuss real analysis, and today our topic is addition of parameter. It is an important topic for us. So we first of all defined what is an addition of parameter. Let f be an real valued function in domain D2 R be a real valued functions. Now take an partition, say p equal to x0 x1 xn, where x0 less than equal to less than x1 less than x2 xn. And for this partition, now we take a set which is defined as f of x1 minus f of x0 plus f of x2 minus f of x1 plus f of xn minus f of xn minus 1. Now if the set Vf is bounded above, then we say that the map f is a functions of bounded variations and bounded variation for any partition P on a partition of a set D. So what is bounded variation? So for any partitions, if we define a set, and if this set is bounded above, then we say that f is a function of bounded variation. Now the question is, find f is a map from -1 to 1 to R be a function defined by f of x equal to x square cos 1 by x where x not equal to 0 and 0 where x equal to 0. Then the option says f is bounded variation on -1 to 1, f dash is bounded variations on -1 to 1, f dash mod of f dash x less than equal to 1 for all -1 to 1, and mod of f dash less than equal to 3 for all -1 to 1. Now the function is f of x equal to x square cos 1 by x. Then what is, and for what option these are bounded variations. Now we state an standard theorem. This theorem says if f is differentiable on its domain, and if the derivative is bounded on that domain, then f is a bounded variation on that domain, and you can prove it. This is a very easy proof, and you prove it from the Lagrange mean value theorem. Now the map is this, and so f dash x becomes 2x cos 1 by x into sine 1 by x, and you see that f is always, and f is here, f is continuous on minus 1 to 1, and actually the problem is 0 point, but in 0 point the map is, the limit of this map is 0, so f is continuous on minus 1 to 1, and f dash x is, and also f is differentiable, and also f is differentiable on minus 1 to 1, and the derivative is when x not equal to 0, and the mod of f dash x becomes, and when x equal to 0 this becomes simply 0, and mod of fx equal to 2x cos 1 by x plus sine 1 by x, and this is naturally, mod of f dash x equal to 2x cos 1 by x plus sine 1 by x less than equal to 2 mod x plus 1, since mod of cos 1 by x less than equal to 1 and sine 1 by x less than equal to 1, and this is less than 2 plus 1, since mod of x less than equal to 1 on minus 1 to 1. So mod of f dash x less than equal to 3 for all x belongs to minus 1 to 1. Therefore the fourth option is true and the third option is false. Now we check f is bounded variation on minus 1 to 1, and since f is differentiable, and since f is differentiable on minus 1 to 1, and derivative is bounded, and derivative is bounded, so f is a function of bounded variation. So that's why the first option is true. Now we check the second option. Second option says f dash x is bounded variation on minus 1 to 1. Now f dash x becomes 2x cos 1 by x plus sine 1 by x. Now we take and partitions on, on 0 to 2 by pi, and this is a subset of minus 1 to 1, and the partitions becomes p equal to 0 2 by 1 by n pi 2 into 2n minus 1 pi 1 by n minus 1 pi dot 1 by pi, and the last one is 2, and the last one is 2 by pi. So this is a partition on the set, and f of, and not f dash of, and f dash is this. So f dash of 1 by r pi becomes 2 by r pi cos of r pi plus sine of r pi, and this becomes minus 1 to the power r 2 by r pi, where r equal to 1 2, and f dash 2 by 2r minus 1 pi, this is becomes 2 into 2 of 2r minus 1 pi plus cos of 2r minus 1 by 2 pi plus sine of 2r minus I by 2 pi, and this is first term is 0 and the remaining term is r to the power 1 for r equal to 1 to dot dot dot. Now for these partitions we define f dash, and now v of pf becomes mod of f of 1 by n pi minus f of 0 plus mod of f of 2 by 2n minus 1 pi minus f of 1 by n pi plus f of n minus 1 pi minus f of 2 by 2n minus 1 pi plus dot 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 f of 2 by pi minus f of 1 by pi. So this becomes f of 1 pi, and this is becomes mod of minus 1 to the power n into 2 by n pi, and this is 0 plus this becomes, from here this becomes minus 1 to the power n plus 1 minus 1 to the power n 2 by n pi plus this becomes minus 1 to the power n minus 1 2 into n minus 1 pi minus 1 to the power n, and this is minus 1 to the power n plus 1 plus dot 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 f of 2 by pi, this becomes f of 2 by pi, this is minus 1 and this is minus 1 by 2 by pi. So this is 2 by n pi plus, this is a modulus, so this is 1 plus 2 by n pi plus 2 by n minus 1 pi plus 1 plus dot dot dot, this becomes 1 plus 2 by pi. So 2 by pi, taking 2 by pi, actually this is 2 into 2 by pi, because 2 by pi, this is 2 by pi, and 1 1, so this becomes 1 by n plus 1 by n minus 1 plus dot 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 1, and this is 2 into n, because n times 1 into 2 2n, and so therefore v of pf equal to 4 by pi into 1 plus 1 by 2 1 by n plus 2n. And friends, you know that this is not unbounded, because as n tends to infinity, this series is diverged and this is also diverged. So f dash, so f dash is not a function of bounded, f is not a function of bounded variations on this 0 to 2 by pi, and this is a subset of minus 1 to 1. Since f is not an bounded variation, f dash is not a bounded variation on in a small set, so this is not a bounded variation on minus 1 to 1. So that's why, and this is a superset of this, and since this f dash is not a bounded variation on this set, so f dash is not a bounded variation this set also. So therefore the options f dash is a bounded variation is wrong, and the right option is A and D. Thank you.